Hey, this is Sean with Math Swap Tutoring, the owner and lead tutor. And today I want to talk about the Algebra 1 concept of real numbers. All right, so I admit when I was in school, I kind of understood this, but it was just kind of like, okay, let me just get over this vocabulary. Um, I kind of understand it, I kind of don't. But yeah, let's try to get some understanding of this because all of these things actually mean something. So make sure that you watch it a few times if you need to. And if it's not as clear, just let me know in the comments and I'll try to clarify it. Okay. All right. So let's go ahead and pull up this whiteboard real quick. We're going to talk about real numbers. So that's right there here as this comes up. Okay. So real numbers. Oh. Now, it's important to note that whenever we're talking about real numbers, there is a such thing as the opposite of real numbers, which is called imaginary numbers. So let's talk about that. In other words, we're going to define what a real number is by defining what an imaginary number is. Okay, so let's say, what is an imaginary number? An imaginary number. All right, so listen to me in brief right now to kind of understand what a imaginary number is. An imaginary number is essentially a number that is denoted by a number followed by the letter I. Usually it's the letter I, sometimes it's the letter J. So say, for example, we have 2I. So what in the world is I? This essentially is what helps you to know that this is an imaginary number. Where this comes from is specifically when we try to take the square root, the fourth root, like a positive, not positive, but an even root of a negative number. This is what I mean. So say, for example, this would be the square root of -4. So think about that. Let's look at the square root of +4. So square root, all that is basically like, it's asking what number do you have to multiply times itself twice to get the number on the inside. What number do you have to get? Do you use to multiply times itself 2 times? What I mean is the number times itself, and then you get this. And so we know that the square root of 4 is 2. The square root of 4 is 2. So that means the number that you use to multiply times itself, it times itself. So that means 2 of that number, it'll give you 4. 2 times 2 gives you 4. So therefore, the square root of 4 is 2. Now, what about the square root of -4? So technically, you can't really do that, so to speak. What I mean is, if you were to take the square root of a negative number, what you're asking is, what number times itself can I multiply to give me -4? So I can multiply 2 times 2 and get +4, as we saw right here. But I can't multiply anything times itself to get a negative number. You can multiply 2 times -2, but then again, that's not, neither of those, 2 and -2, neither of those is the square root of this number, because to be a true square root, you have to be able to multiply a number times itself and get the number that's underneath that square root bracket. You see what I'm saying? All right, so what happens is, anytime you take the square root of a negative number, you get that I. So that's why we have 2I. So the square root of 4 is 2, but whenever you take the square root of a negative number, you get this I piece right here. So it goes, I'll go on to say, that's where you have this whole situation here. So how do I say this? So I is equal to, I mean, I squared is equal to -1. I cubed is equal to negative I, and I to the fourth is equal to I. And of course, as we established here, the square root of I is -1. I mean, the square root of -1 is I. I squared, which is, so check it out. I squared is this I, which is square root of -1 times the square root of -1. So anytime you multiply something times square root times the square root, you just get the number underneath. So that just equals -1. And then I cubed is I squared times I. So that's -1 times I. So it's negative I. And then I to the fourth is just, I mean, I'm sorry, I wrote that incorrectly. I to the fourth is 1, it's not I. So I squared is -1 times another I squared would be -1 times -1 is equal to 1. Okay, so this tutorial is not so much about imaginary numbers. It's really more so telling you what real numbers are by telling you what imaginary numbers are. Okay, so now, what is a real number? So a real number obviously is not imaginary. So you're not going to have this situation where you have a square root or an even root of a negative number. So a real number is anything that doesn't come under that umbrella. So basically, so first of all, real numbers are not imaginary numbers. In other words, there's no I there. There's never going to be an I in a real number. You're not going to take the square root of a negative number and it be real. It can't be real. Next thing is, a real number is classified as either rational or irrational. Okay, so what does that mean? A real number is rational or irrational. So let's break it down. So that means there are two types of real numbers. This is type number 1, rational. This is type number 2, irrational. So a rational number is essentially, and now just hear me for a second, because this kind of sounds, this is some of that weird sounding definition stuff, but I promise you, if you just kind of slow down, it makes sense. A rational number is a number that can be expressed as the quotient of an integer divided by a non-zero integer. All right, so what does that mean? What in the world does that mean? So a rational number is a number that it can be described or defined as an integer divided by a non-zero integer. The quotient. So all a quotient is the answer to a division problem. A fraction really is kind of like a division problem. This line represents a division sign, really. So whatever number comes out of this division problem right here, as long as it is it's an integer divided by a non-zero integer, you can never have you can never divide by 0. That kind of number is considered undefined. This is a rational number. Now, the other thing with a rational number is that the decimal representation terminates or repeats. Okay. All right. So we have that. So what about, and I promise we're going to define this a little bit better in a little bit. So what about irrational numbers? Irrational numbers cannot be defined as an integer divided by a non-zero integer. So let me put an X through that. An irrational number cannot be defined as an integer divided by an integer. And the decimal representation, I don't want that in that color. The decimal representation of an irrational number does not terminate or repeat. All right, so all of this is probably a little bit of gibberish, especially if you're not as familiar with this. But I promise you, if you just kind of look and see, you understand exactly why they say these things. All right, so let's go back and we're going to give you some examples of rational numbers. Oh yeah, I forget. Let's define what an integer is. An integer, all an integer is really is just a whole number. So that could be, like 1, 2, 3, 4, 5, so on and so forth, or 0, -1, -2, -3, -4. Any whole number is an integer. That's all that is. And again, they also say non-zero integer because you don't want a situation where you have a zero in the denominator of a fraction, or you're dividing a number by 0. That's undefined. All right. So a rational number can be defined as some integer, 1, 2, 3, 4, 5, -1, -2, whatever, divided by some other integer, as long as it's not 0, and the decimal representation terminates or repeats. So for example, 1 is an integer. It can be defined as 1 divided by 1, or 2 divided by 2, or 80 divided by 80. Let's see. 0.5 is an integer. Now, I know what you might be thinking, but it's not a whole number. Now, remember, we're not talking so much about integers right now. We are talking about rational numbers. So the reason why 0.5 is a rational number, first of all, it is real. It's not imaginary. We have no eyes here. Second of all, it can be represented as an integer over a non-zero integer. 0.5 is the same thing as 1/2. An integer over a non-zero integer. And then also the decimal representation of this number terminates or repeats. That means that whenever you have the decimal form of this number, the decimal stops. You have some numbers that the decimal goes on and on and on and on and on without ever ending. But 1/2 is simply 0.5. That's all it is. So it terminates. Okay, another good example is, and I probably should put the fraction version first, 1/3. So first of all, it is an integer over a non-zero integer. And what is the decimal representation of 1/3? It is 0.33 repeated. So that means it's 0.333333 forever. So the decimal representation of 1/3 repeats. The decimal representation of 1/2 terminates. So both of these are good examples of rational numbers. Now, what about irrational numbers? The main thing to really harp on is this piece right here, that, well, really both of them, irrational numbers cannot be defined as an integer over a non-zero integer. The decimal does not terminate or repeat. So let's define this by giving a couple of common constants that we know of that are irrational. So for example, pi. Pi is an irrational number. First of all, all pi is like a measure of, it's like a ratio between, I believe it's the diameter of a circle and its circumference or something like that. I need to go back and look, but it's something like that. So anyhow, it is not defined by some integer over a non-zero integer. Pi is equal to 3.1415 9, 2, 6, 5, 4, and it goes on and on and on and on and on. So you see very clearly this decimal representation does not terminate or repeat. It goes on and on forever. This is clearly irrational. There's another constant called E, and I can't remember it. This is something we talked about a lot in engineering school. But E is another example of a constant that is very useful for a different kind of applications. But it's equal to 2.7182818, and it goes on and on and on forever. Clearly irrational. You can't really define that. There is no something divided by something gives you 2.71828. There is nothing like that. And then you see very clearly by the decimal representation that it goes on and on. It doesn't terminate or repeat. Okay. So yeah, so there we go. So that's the main thing. So basically what we've covered here, we've told you what real numbers are. So real numbers are not imaginary numbers. So that means they don't have any sort of square root of a negative number involved, or like an even root of a negative number. Real numbers are also defined as either irrational or rational. And you see here, rational can be defined as an integer divided by another integer, as long as it's not 0. And then the decimal representation either terminates or repeats. Irrational, there is no clear integer divided by a non-zero integer that you can represent it with, and the decimal representation goes on and on and on and on and on forever. That's it. If you have any other questions, let me know. Put it in the comments. And if you need tutoring in Algebra 1, make sure you reach out to us. Look in the description. And oh yeah, and then also I have my notes for this video available at mathswaptutoring.com, specifically for those of you who subscribe at mathswaptutoring.com/subscribe. Okay. All right. Hope this has been helpful. Y'all take care, and I hope you will join me next time. All right.